Hi. So in this exercise we're going to be looking at Fibonacci from a viewpoint of recursion and performance, always a favorite. And we'll be looking at different approaches to doing the same problem by giving us the nth Fibonacci. And we'll be looking at recursion versus iteration to see how performant each is. And we'll be doing an application code walkthrough of that. Let's get started. In this exercise we'll be looking at performance, and we'll be using Fibonacci, an old favorite, and we'll be comparing different approaches, including the classic recursion approach, to see how they perform. So let's run our tests, and I've written some here to do some very crude timing before I even realized that I was given that myself, but the numbers pretty much match, and they take the different approaches. They calculate a large Fibonacci, like the 1400th, and then because that was so fast, less than milliseconds, I did it 10,000 times, which of course there will be the machine will be doing a lot of caching and performance stuff, but it's a crude way to at least start poking at performance, to see how it goes. So I did this a couple of ways, using a for loop and a while loop, fairly similar timing here. When I went to do it using it without recursion, and when I went to do it with recursion, I was actually only able to get up to the number 40 once before I got a Stack Overflow, and it took longer. So recursion was not a good approach timing wise for that. And then I tried to go with a number that I could do 10,000 times. I could only get up to 20 instead of the 1400. And still taking longer, a little bit longer. And then, interesting though, a final approach that I did was using recursion, but it was making use of memoization, and that managed to do the 1400, the 10,000 times. It did take, considerably longer than the first couple of just plain iterative ways, but compared to the other recursive ways, it's a massive difference. So those are that's the output there. So let's take a look at the code itself. Let's take a quick look at the tests just to see the format that they have. So you see they're named here, the for, the while. There are a couple of recursives. There's a before that grabs the time, and after that does results, just down here at the bottom. Oops. It just does diff and prints out the difference in times. And then code itself here just basically calls those functions, and for the ones where it's doing performance, it does it like 10,000 times. I changed this just because I was sneaking around some code warnings about duplicate stuff. But I do go from 3 to 10,003 and 2 to 10,002, so it's actually the same number of iterations. But it's not clear from the code why I did that, which is definitely a code smell. Alright, so that's the tests. Now let's take a look at the code itself. So here's the for loop, pretty simple and classic for loop, like a C1 almost. And it just loops around, doing the current plus next, and then doing that little formula that you do for Fibonacci, for the nth Fibonacci. And this splice at the end is one of the interesting parts, because I end up with an array of all the Fibonacci's. Maybe I didn't actually need to keep track of that array, but that was my original approach. And here I'm just taking the last element, and then I'm just taking the 0 to take the element out of the array and just return the element itself. So this was the Fibonacci one. It actually looks pretty similar, because it basically is. The code bit here is the same. This is just the way that it iterates, but it's still very similar, and that's why the timing ended up being the same. I'll use the same splice out here. And then here's the recursive ones. Pretty short, obviously. You don't need a lot of code to do the recursive stuff. So this was the one that was very unperformant, doing it this way. And then this is the one with the memoization, where basically when you calculate something, if you've calculated it, you keep track of it. so that if you've already calculated it, you don't need to calculate it again every time you go through the loop. It's just a very simple little formula like that. So that's basically just a little peek at performance and a way, without using any tools, at measuring it. Thank you.